Bismillahirrahmanirrahim. Let's start the second part of the lecture, in which we will quickly go through and we will revise the whole stuff we did in the last lecture. So we will start from the book, right? 5.02 is the example. This is the uniformly distributed load W. W is always load per unit length, right? As we have already discussed that we will make a free body diagram. We will represent W as Wx, and where x is the span length on which that is being applied, right? And it is generally applied exactly in the center of the section, right? If this is the section I am taking at any point x, right? So it will be always applied at the center, right? So this is just to calculate the reactions and the loads, but we cannot decide the shape of the bending moment or the diagrams, right? We have to calculate first reactions as well as the shear forces and the bending moments, and then according to the values coming from those mathematics, then we draw the shape of the bending moment and the shear force diagrams, right? So if it is x, so again this is from the, we are taking from the left to right, so these are the positive conventions for us, right? We are assuming that this is the positive movements. So when it is, so then we'll apply sum of all the forces about yx is equal to 0. So w is load per unit length multiplied by the section length. So length will cancel with the length, so you will left with only load. Okay, that is in the negative direction, so minus wx, and v is also statically negative y direction, so minus v equals to 0, so v is equal to minus wx, right? And when we will calculate the moment, so obviously wx about this point, about c, we are calculating the moments now because we want to calculate v over m over here, right? So we will take the moment about this, so wx into x by 2, this is again, this will try to rotate this into this direction, right? This is the counterclockwise, so counterclockwise, statically counterclockwise is positive, so it is positive. This is again positive, this m is again positive, so sum of action plus reaction equals to 0, so m is minus half omega wx square, right? So x square is the quadratic one, so we will get the parabola for the moment diagram like over here, and for the whole length x will be replaced with the L, so mb will be minus half wl square, right? And for shear, since shear force is directly dependent on the x only, so it will be the linear one. Since it is a negative one, so it will be the negative part of this one. So both v will be in negative part because it is minus omega wx, and moment will also be into the negative one, that will be the positive negative one. And if we just assume that how it will bend, it is a cantilever, and we know that cantilever, how the cantilever will bend against this load, it will be in the negative sad face will be there, and top will be in the tension, and the bottom will be in the compression, so everything will be in the negative one, because we know whenever we have a cantilever and we have a cantilever, at the base B, it is always maximum moment, and the shear force will be again maximum, because length will be maximum when you have the uniformly distributed load in it, right? So from that shape, if you remember the sign convention, it will be a sad face mean moment will be negative, as well as uh, the shear force will be also negative, right? Now we will come to the example 5.1. We will quickly, we have already gone through it, right? So here they calculated M2. M2 is this one. So statically 20 is negative, downward, negative y direction. V2 is again negative y direction. So minus 20 kilonewton minus V2 is equal to 0, right? And when we will draw the moment diagram, 20 into 2.5 is the maximum length you have, section length for this, plus M2. M2 is statically positive. This is again statically positive because it is counterclockwise, so we will go for it, and then we will keep on calculating accordingly. One thing I want to show over here is this one. These all sections are from left to right, but this is from right to left. If we take the left to right, right to left, then we have to change the convention as we discussed in the last lecture, right? So now these will be the directions for the movements and the V's. This is opposite to that one, because if I cut the section over here, this part which is not showing over here will be having opposite to each other to make it, to keep it into the equilibrium, right? So so that will be downward. In this section, in this part, that will be downward, and that will be in this direction, right, to counter that one, right? So when we will go for that, so we will see how we calculate that. This is the V4 calculated from left to right. This is the V4 calculated from right to left by taking this convention. So V4 V4 is this one, that is statically positive one. This is 14 statically positive one. This is 40 statically negative one. So we will end up with the 26 one, 26 kilonewton V4. Now calculate the M, right? So this is statically negative one because counter, this is clockwise, right? So minus M4 plus 14 into this section length, that is 2, right? And there will be no contribution from the 40 because 40 this is a very nominal length over here. So a moment about 40 a moment because of the 40 kilonewton load will be 0, so M will be 28. So in both cases you will be getting same results, V4 and M4, if you go from the right to left or left to right, but it all depends how you take the convention. So it should always be, that should be remembered to you, that how, when will you go from left to right, what sort of positive convention will be there, and when you will go for the from right to left, what sort of convention will be there for the both uh, for the both moments and the negative one. So sign convention will be helpful over here. Otherwise everything will be done statically, right? Calculation of the moment and the shear force, that will be pure static part, and on the basis of that static part you calculate these loads, and then you decide what shape that will be over there. You draw the sections and then keep on putting the loads and drawing the lines, that may be a slopy lines or the straight line depending upon the nature of the loads. Again, this was discussed, we discussed one, right, over here. So it is obvious over there that moment will be 96 minus 24x. Obviously this will be a straight line because moment depends on the x. It is not x square. X square is over here. It is x square, so it will be parabola over here, or the quadratic dependency of the moment on that. X is the linear one, so these are all straight lines. So 96 minus 24, maximum length is 11 for this. So 96 minus 24 multiplied by 11 will be somewhere on the 168 kip feet. And then you will minus this 20 because this is the negative one, because this is counterclockwise, this is clockwise, so we will subtract this from 168, so it will be 148. So this just before this point it will be 168 kips fit, and point just after this point it will be minus 148, right? Likewise, moment dependency for the last one, a last section over here is 226 minus 34 x maximum is now 16, so you will put 16 over here. So 226 minus 34 multiplied by 16, it will be minus 318 kips. It will be the last point over here, right? And then to the left of D, we have already this, to the left of D, it will be minus 168 kips fit, minus 168 multiplied by 12 will be kips inch. Likewise, minus 148 multiplied by 12 will be right of the D, just right of the D. That will be the kips inch over there, right? So this is how you will complete your section. And then in the next lecture we will discuss about the shear force bending moment diagram and the their dependency on the integrations and the derivations. So we will stop here. So we will have our interactive session on this. So please try to solve all these questions so that you can have a better idea how to do all this stuff, right? Thank you.